Kia ora. WIDS Auckland 2020 is an online series of talks from women sharing their stories about their work and career contributions across many industries and in academia. WIDS Auckland is an independent event organised by the University of Auckland Faculty of Engineering to coincide with the annual Global Women in Data Science Conference. I'm Rosalind Archer, a WIDS ambassador, and I'm delighted to be sharing these inspiring talks. I'd like to thank the WIDS Auckland sponsors, gold sponsor Stats New Zealand, silver sponsors SAS, the Ministry of Business, Innovation and Employment, Finity Consulting, Servian, Todd Digital and Red Hat. This talk will be presented by Diana Benavides Prado from Auckland University of Technology. She's presenting on high-stakes data science for social good.
So, hi everyone, my name is Diana. I'm a senior data scientist at the Center for Social Data Analytics. Today, I'm going to share with you my experience as a data scientist in the implementation of the Allegheny Family Screening Tool, which is a machine learning model that helps college screening staff in Allegheny County to make the process of screening referrals of maltreatment to children. And I would like to start with some context of the problem that we are working on here. So unfortunately, around the world, there are some very concerning numbers around the maltreatment of children. And we have like around 40 million of children subject to some type of maltreatment around the world per year. And in US only, the Child Welfare Agency receives millions of calls per year reporting some type of maltreatment or neglect for children. So those numbers are extremely concerning, and in the US in particular, the child protection agencies, the child protection services, which are administered by each state or each county, have a series of common concerns around reports of maltreatment events for children around the country. So they are particularly concerned around the screening decisions, those key decisions when someone reports that a child is suffering those types of maltreatment events. So they want to be as effective as possible into deciding, for example, which of those reports should be screened out without further investigation and which ones should be screening for further in-person investigation. They want to optimize as much as possible the efforts spent into investigating the families who are actually at risk of further maltreatment events. And they also want to approach those families in the right time without delays in providing those families with the services that they potentially need to solve those maltreatment situations going on. Allegheny County in particular has around 14,000 million calls, so they have a hotline to actually where like people from the community, like school teachers or like neighbors in general around the county, can call and report that a child is actually suffering those kinds of events of maltreatment. So there are 14,000 of those calls per year. And the people attending those calls actually face like a very challenging decision, because it's that at that point on the call when they have to decide whether that event of maltreatment that is being reported is concerning enough to actually deserve more in-person investigation. So around half of those calls are actually screening for further investigation, and half of them are considered not concerning enough to an in-person investigation. So this is a more detailed depiction of the screening process in the Allegheny County Department of Human Services. And as I have mentioned, the key decision, which is right in the middle of the diagram, is whether to screen in or screen out a referral reporting maltreatment of a child in the county. And for that, before the introduction of the Allegheny Family Screening Tool, AFST, what the call screening staff used to do was to collect information regarding the child himself or members of the family of the child, and using that information and all of the information reported in the current referral, such as, for example, where the child is suffering physical abuse or someone is reporting neglect of the child. Using that information, the call screening staff used to determine how concerning was that particular referral and whether that referral deserved further in-person investigation or not. So the Allegheny Family Screening Tool, as I have mentioned, is comes from a question that we were asking ourselves, in the sense that whether we could use the rich and highly integrated data in Allegheny County to actually build a predictive risk model that could help prioritize those families that actually deserve further investigation at the call screening point. One of the challenges that we faced when we actually had this idea of using the rich variety of data in Allegheny County to construct a machine learning predictive model was, which outcome do we want to predict? So we want to help the call screening staff to determine whether one of those families being reported is suffering maltreatment, concerning maltreatment events or not, with respect also to other families being reported, to decide which ones of them were deserved to be prioritized for further investigation and later on for further services. And in child maltreatment, determining the outcome of future maltreatment is quite difficult, because it's not like an outcome in the clinical setting when you can observe, for example, outcomes of mortality or outcomes related to particular diseases. And in the child welfare setting, that outcome is more abstract. So we had to spend quite an amount of time trying to find the right outcome or target variable for the machine learning model. So the outcome that the model is currently using is removal of the child out of home, placement out of home, within a period of 2 years. And that outcome seemed to be a good proxy to determine the long-arm risk of maltreatment that we wanted to help to determine, to effectively prioritize those families for further investigation and or services. So as I have mentioned before, the machine learning model supporting the AFST was constructed on the idea of exploiting all of the available data on the Allegheny County data warehouse that contain information, for example, regarding demographics of the members of those families being reported, other aspects such as, I don't know, like behavioral health records of those members of the family, if there was any, previous child welfare services provided to members of those families, etc. And what we did in order to construct the set of input features of the machine learning model, which is around 400 features so far, is basically arrange all of those characteristics of the members of the family that we could find in the Allegheny data warehouse into a data set describing those aspects of each person mentioned in each of those referrals or calls reporting maltreatment. This is how the AFST looks like for the decision makers, for the call screening staff at Allegheny County. This tool has been running since August 2016. And basically what the tool provides to the decision makers is this additional piece of information, which is a risk score of placement within 2 years. And the risk score goes in a scale of 1 to 20, where a 1 means that according to the historic information that the model is using and the outcome that we are aiming to predict with that historic information, this family doesn't seem to have a high risk of those children to be placed out of home within 2 years, while a score of 20 means that there is a high risk of those children facing that outcome, and this suggests to the call screening staff to actually spend more effort on those families which are classified as high risk, and to screen those families for further investigation. So as you can imagine, by the introduction of the AFST, effectively the screening process at Allegheny County was slightly changed, in the sense, as you can see, the green element here. What the AFST provides now in the screening process is this additional piece of information that, again, the usual decision makers, the call screening staff, can use to enrich that information that they have to make that critical decision of screening in or screening out a referral for further investigation. So after implementing the first version of the Allegheny Family Screening Tool, we had like many lessons learned, but I would like to focus in 3 of those lessons, which are like the most relevant here. The first one is, of course, the accuracy of the model is extremely important, and that's part of the further explorations of further versions of the tool. And deploying a machine learning model to support decision making in real world settings is much harder than we as data scientists can imagine. So there are several challenges in that setting that I'm going to mention in the next section as well. And contextualizing those machine learning solutions that we can imagine and experiment with in the technical setting in high stakes problems, like providing this piece of information to decision makers that are going to make those decisions with impact on real people is very important. So we need to make sure that we involve the right people into the whole process of experimenting with and deploying the solutions, such as the staff that is actually going to use the tool, the community who is potentially going to be impacted by the decisions made with the support of that tool, and also the internal leadership and the internal staff who is involved into the deployment of these kinds of tools. So after August 2016, we have been working on continuously refining the AFST, and 2 big pieces of refining the tool have been concentrated on improving the accuracy of the tool. So we explored things such as alternative modeling techniques to the modeling technique that we used in the first version of the tool, which was a logistic regression. And we also have been exploring aspects such as how the accuracy looks like for particular subgroups of that community, which is being impacted by those decisions, such as, for example, subgroups based on race. The second goal of the refinement of AFST has been to continuously improve the technical deployment of the tool. So, for example, by looking at if there are new features that can be potentially used for as input features of the model, or if there are any changes in the business process that we need to take into account and that actually impact the design of the tool. So in terms of our efforts on improving the accuracy of the AFST, we have been exploring alternative modeling techniques that data scientists may be familiar with, from the family of regression and ensemble methods, given the characteristic of our input data, which is highly transactional. So in the regression methods, we have explored methods such as the original logistic regression, but also alternative methods such as lasso regression, and from the group of ensemble methods, random forest and extreme gradient boosting methods. Based on the exploration of those methods, we typically evaluate the performance of each of those candidate models in terms of standard metrics, such as the area under the receiver operating characteristic, the AUC, true positive rates and false positive rates at certain thresholds, because we are particularly interested into identifying with high accuracy those families who are like in high risk of the outcome that the model uses. So as you can see here, methods such as random forest, extreme gradient boosting, and lasso have reasonably similar AUCs and similar performance in terms of the other metrics that we have considered to decide which model to use. At the end of this experimentation, we decided to, for the second and third versions of the tool that have been already deployed, we decided to use a lasso regression. And the reason for that, apart from the competitive accuracy that the model provides us, is basically, to some extent, the interpretability of how the model is represented as compared to methods such as random forest and extreme gradient boosting. Apart from checking the performance in terms of the outcome that we use to train the model, we have also been interested in looking at how the model is potentially sensitive to other external outcomes that we can, that are also related to maltreatment. So what we did was to link the data used for the AFST to data on hospitalizations of children in the county to try to determine whether the model was effectively sensitive to those events of maltreatment, such as those kinds of hospitalizations. As we can see here, while we go in the x-axis from the 1 to 20 in the risk score of the model that predicts placement, we can see that as we see a gradient here, the higher the risk score of placement on the AFST, the higher the number of hospitalization events related to those to maltreatment that we can see. So the tool seems to be actually sensitive to those other types of events of indicating maltreatment of those children. Another aspect that we have been interested in looking at is how the AFST model is calibrated for accuracy across different subgroups based on race. So in Allegheny County, the child welfare system is, there is like an acknowledgement that there may be some disparities in terms of racial subgroups because there is a tendency of receiving higher number of referrals, higher number of reports for certain subgroups of the population, such as, for example, Black families. So we wanted to look at how the fact of observing more referrals in the training data for that particular subgroup could potentially affect the accuracy of the model for that particular subgroup. So this plot shows a comparison of, again, how the predicted risk score in the scale from 1 to 20 looks like for Black and white subgroups, and how the observed placement rate looks like across those different predicted risk categories in the x-axis. So for a perfect world, for a perfectly calibrated model, we would expect to see a gradient as well here, but the gradient would be exactly the same for the different subgroups. What we can see here in this plot is that actually the observed placement rate seems to be higher for the Black group, especially in the high risk categories, which seems to denote that the model is actually more sensitive to that outcome for the African American subgroups. In terms of the second goal, improving deployment, as I have mentioned before, from my experience, there are several things that can go wrong when we actually move from our perfectly controlled experimental setting of our model to real world operation, where we have to actually provide those risk scores to actual decision makers in real time, when we have to actually calculate that score using only the information that is available at that point in time. So it's kind of a very different setting from that setting when we are experimenting and have things control, especially related to the data that we use to experiment with the model. So there are some key questions that I would suggest to explore when we are actually deploying these kinds of tools. One of them is ask ourselves how the data the model is supposed to be using to calculate those predictions in the operation part of it is if that data is actually going to be available, or if there will be like delays on observing the data and how that is going to impact the model. Is it possible to collect whole history in real time? Are we, for example, going to be able to observe all of the people that we are supposed to observe in real time, in particular in the AFST, because we want to grab as much history of all of the members of the families as possible. It is very important that we are able to observe those clients, or those like the IDs of those persons correctly. And if there are any potential feedback loops to consider. So what did we learn while refining the AFST? One of the things is that continuous monitoring and improvement of the experimentation and deployment of the model continue to be super important, and also that measuring impact is fundamental for determining where the tool, for example, requires further improvement, or where the tool is actually working in the way that we expect the tool to work. So in the last part, I'm going to quickly mention some conclusions that we have so far regarding the impact of the AFST and aspects around continuous evaluation of the tool. So impact evaluation, there was an independent group and Stanford that during 2018 and 19 work on effectively determining how the AFST had impacted the process of deciding on screening decisions. So I am listing here like two of the main conclusions, like the most, that I consider the most relevant so far and more insightful for me as a data scientist. One of them is that the AFST actually helped to increase the identification of children determined to be in need of further child welfare intervention, or further attention from the child welfare system. And the other one, which is surprising one, but also extremely good to observe, is that the AFST has actually led to reductions in disparities in opening of cases between Black and white children. In terms of continuous monitoring, as I have said, this is an aspect that should be paid attention to, and we do a lot of continuous monitoring, but one of the example things that we do is, for example, measure the accuracy of the tool, what we call in the field. So this is an example of one of the experiments that we commonly do, where we take the data set that we use to build the model, which in this slide is called the research data set, and we compare that and how that looks as opposed to data collected after the tool was deployed. And what we wanted to look at here is where the accuracy had changed when we compare those two periods of time, like pre-implementation and post-implementation of the tool. And as we can see in the metrics here, the placement rate has changed a little bit, but the area and the receiving operating characteristic, the AUC metrics and the AUC for the particular subgroup of Black has basically remained the same, which is a good indication that the tool is still applicable to the data that is being collected in real time. So some final remarks. I think I have tried to remark my lessons as a data scientist during this project, but I would like to mention three final things. One of them is that we as data scientists sometimes tend to be very technical, and I know that there are like a lot of very good data scientists out there, but from my experience with the AFST, I think that this technical expertise should always be accompanied by context. So we should always be thinking on the problem domain, we should always be thinking on who is going to use this tool that I'm developing and I'm experimenting with, who is going to be impacted by the decisions made with the support of this tool, those kinds of things. It is also important from the very beginning of our data science projects to establish some very good and close collaborations with a bunch of people involved in the process of thinking on designing and deploying these kinds of tools, such as the leadership, the domain expert, the actual decision makers, and the people and the subgroups of the community who are going to be impacted by those decisions. And the final lesson that I have to some extent mentioned before is that as data scientists, we should always act with the right level of ethics and with this awareness that in cases like the AFST, those things that we are doing in the technical side are actually going to have an impact on real human beings. So we should always incorporate that thinking into all of the technical decisions and how we run the process of designing and deploying these kinds of solutions. Thanks very much for your attention.